Shh. All right, look, I'm starting the record. All right, so section 2 through 5, this is a recap of this section from our notes. 4.2, the atom. 4.3, elements in the periodic table. 4.4, reactivity. And 4.5, bonding. Yes. Okay, so starting with 4.2. I got 10 minutes. Got 10 minutes starting here. Okay. The simplest section is this one, which is basically just consisting of vocabulary words that you need to memorize and be able to distinguish between these words. Okay, these words. All right. We get confused. You guys, a lot of the quizzes that I went back through and looked at, there was a lot of confusion here between. A lot of people miss questions about those three particles, the three subatomic particles of an atom. Protons are positive, electrons are negative, neutrons are neutral. Okay, you just got to remember that somehow or another. I think of electricity when I think of electrons. All right, the electron cloud, orbital, all that's kind of, there's tons of different words that are used or phrases that are used to describe the area outside of the nucleus. Okay. All right, so that really short and sweet section 2. All right. Now a lot of you answered atom on quizzes instead of element. Okay. Elements, by definition, are the substances that cannot be broken down into anything smaller or simpler. That's not the definition of an atom. A lot of you guys put atom in for element on the quiz, on that 4.2, 4.3 quiz. Okay. You have to be able to differentiate between the number. A lot of confusion here between number and mass. Okay, the number is listed on the periodic table to identify the elements, and the number represents the number of protons in its nucleus. The mass represents the protons plus the neutrons. Okay, so mass equals P plus N. All right. Now, if you're given the mass and you're given the protons, you can use algebra to figure out how many neutrons there are in the atom. Okay, because if you need to figure out how many neutrons are in a carbon-12 atom, then you just take the mass and subtract the protons, and that's how many neutrons. Okay, the mass of the atom is in the nucleus. What parts of the which subatomic particles can be found in the nucleus?
Protons and neutrons.
Protons and neutrons are found in the nucleus. Okay. Neutrons don't have a charge. All right. Now the atomic number, okay, here is carbon-12. Remember, this is an isotope of carbon. There's carbon-12, carbon-13, carbon-14. The difference between carbon-12, carbon-13, and carbon-14 is the number of neutrons. Okay? They all have different numbers of neutrons. So basically the only difference in those three is that they have different masses. They're the same chemical structure. They have the same protons, same electrons. They just have different masses because the mass is in the nucleus. Because there's a different number of neutrons, the mass is different. Okay. Here's the atomic number, which equals the protons. And if it is an atom, right, then the protons equal the neutrons. Excuse me. Scratch that. Protons equal electrons. Okay? If it is an atom, then protons equal electrons. Why? Because atoms are neutral, by definition. And so if it's neutral, then it's going to have the same number of positive parts and negative parts because they will balance out and be neutral. Okay? All right. This little section right here tells me how many electrons carbon has on each energy level or in each orbital. They all always have 2 on the first, and then so this is telling me that there's 4 on the second. Right? Here's the mass. That's how you read that. When you're drawing atoms, you can look at this table and figure out how many dots to put on each energy level. Okay. Again, isotopes are just different versions, and this goes through your how to calculate mass right here. Here's a little tidbit about energy levels. Okay. The first thing is closest. Okay, the first energy level is closest, holds 2. The second holds 8. The third can hold 18, and so on and so forth. We're not going to get into all that because that's more of a chemistry class next year at Madison Central. Okay? And don't let this number confuse you, because to be stable, when we're talking, the reason that we're talking about this section is because we're learning about bonding. And from a bonding standpoint, all you need to know is that an orbital has to have 8 electrons to be stable, and that's what they're trying to do. They're trying to find stability. And they can't find stability unless they have at least 8 electrons in their outer shell. Okay? All right, so that's 4.3. Now the stuff we just took a quiz on today, 4.4. All right. We're going to play a game later called the octet game, called Crazy 8. All right, compounds. Simply a compound is just a combination of 2 or more atoms. A reaction is something that occurs when something is changed. All right. Reactivity is its ability to combine with another element. How reactive is it? Sodium is very reactive with chlorine. Together they make salt, sodium chloride. So sodium is reactive with chlorine. Valence electrons are the ones on the outer shell, and they're the ones that are involved in bonding. Okay? These are the ones that are involved in bonding. The octet rule says that atoms can gain, lose electrons in order to have 8 on their outer energy level. What is that outer energy level called? Which electrons are on the outer energy level? Valence electrons. Okay? So the octet rule states that atoms have a tendency to gain, lose, or share electrons with other atoms in order to have 8. Right? Chemical bond is the attractive forces between atoms when they share or transfer electrons. And the dot diagram is the diagram that we're going to start using when we're referring to bonding, because all we have to do is put dots on it, and we don't have to draw all those rings around it. Okay? The dot diagram represents valence electrons, and that's the only electrons that you need to worry about when it comes to bonding. Okay? You don't have to worry about the inside electrons. So it just makes it more simple for us to draw and write stuff by using the dot diagram structure. Okay? All right, here's some bigger elements. And looking at argon. Argon is a noble gas. It's located on the far right column of the periodic table. It has 8 valence electrons. It is stable. It is not reactive. It's not going to react with anything else because it doesn't need to. It's got everything it needs. So it's going to stay alone. It's independent. Chlorine, however, is not stable. Chlorine gas is very dangerous, a very dangerous atom. But you put it together with sodium, and you've probably already had hundreds and hundreds of milligrams of it this morning. Okay? So you put a dangerous, unstable chlorine atom together with a sodium atom, and they bond to form a compound, and that's perfectly safe. All right? But it's unstable here. That's why it needs to gain 1 to have 8. All right? Valence electrons. So chlorine has 2 on the first level. It has 8 on the second. That's what those numbers mean. And it has 7 on the outside. That's a Bohr diagram. Okay. Easiest way to do this when we're talking about bonding is just to draw dot diagrams. So if I were going to draw a dot diagram of chlorine, I would just draw 7 dots. And that tells me that chlorine has 7 valence electrons. Sodium has 1. Okay, sodium is very reactive with chlorine. It's going to give 1, form a bond, okay, form a bond between these two, become a compound called sodium chloride, aka table salt, and time's up. All right, now, last thing, when chlorine gains an electron, it becomes negatively charged. When sodium gives away an electron, it becomes positively charged. Is sodium an atom now? No, it's an ion.
It's an ion.
Is chlorine an atom now?
It's ion.
No, it's an ion. What type of bond forms between ions? Ionic bond. So find out if it's an ion. If it lost or gained electrons, it became an ion, and the bond that holds 2 ions together is called ionic bond. Okay? All right, time's up. I promised, even though I didn't get to everything.
Oh, shit.
Is there one more section? Yes. Yep.
Why is the atomic mass always a decimal?
How do you get that in?
Well, it's precise. It's just precise and accurate. Like it's down to the nearest, what is that, 1,000ths?
If it's just
Yeah.
protons plus neutrons, then why?
If you, it's just, it's the mass of the atom. It's like weighing this cup. This cup might be 20.526 grams down to the most detailed mass of it. That's just the mass of it.
So what are atoms weighed in?
What?
What are atoms weighed in?
Like what measurement?
Yeah.
What do they weigh in?
Yeah, like grams, pounds, millimeters. I don't know.
Millimeters is distance.
Yeah.
There's a scientific term for it, and I can't remember, that they use to measure the mass of it. All right, this is that last section real quick. This just talks about the different types of bonds, and it's real simple. You just have to study it. All right, and then this last little part here gives you examples of different compounds that are ionically bonded or covalently bonded. All right, remember that metals and nonmetals will always be ionic. If a metal and a nonmetal bond together, they're always ionically bonded. Nonmetals that bond together are covalently. You can memorize that and identify them on tests and not have to worry about it.
So memorize that chart.
I would.